Hello class. We've used arrays previously and we saw that those were considered a collection, and C# offers many additional classes that define different types of collections for you. These are all considered different data structures. We want to look at some of these classes today really quickly: ArrayList, String, BitArray, Hashtable, Queue, and Stack. So every one of these collection classes, like I say, exists as a C# class. Of course, you could create your own or add your own overrides. Our collection classes are all predefined, and they just allow us to store and retrieve predefined objects in a certain way, kind of like our stream reader and stream writer. All of these different classes require us to use the system.collections namespace. Nice collection, huh? The ArrayList class is the first collection class that we'll look at. An ArrayList is zero-based, just like a standard array, meaning the first index value is 0. It's a list-like structure. The difference is that it can dynamically increase and decrease in size, whereas we know a standard array cannot do that. It also supports mixed data types, which again is not something that's supported by a standard array class in C#. Our syntax is our ArrayList class name, followed by the identifier or name we want to give this instance of the ArrayList. The new keyword says to instantiate the instance as an ArrayList object. There are many methods available to the ArrayList class. Take a look at them and do some experimenting. Look at the drop-down available in the Visual Studio IDE as well as the MSDN documentation for all sorts of different information. As you can see, we can do an add to our ArrayList. We could clear it. We could clone it to create a copy. We can remove a specific entry or remove an entry at a specific position. So our remove at method would use an index value to determine which value to remove. Our insert method would do the same thing. We would specify the index location where we wanted to insert the value. So we'll do a little bit of ArrayList testing in your REPL course. The list class uses a generic. That's what the greater than, less than symbols are, the brackets. These brackets indicate that a generic data type will be included there, and we'll talk more about generics in Chapter 11. For now, just know that a list creates a zero-based structure or collection, just like a standard array. The size can dynamically increase or decrease, and it does support generic data typing. It's a little different because we're basically saying that everything in this list will be an integer. So we can't have mixed data types within a list as we can with an array list. However, we can create a list of any type of data, so it can be a little bit more efficient. Our syntax is the list class name, followed by our generic data type, followed by the instance identifier or name of this list. The new keyword instructs the system to instantiate that instance of our list based on this generic data type. In this case, our myList would be an integer list. The string class gives us all sorts of different methods we can use to manipulate strings and compare them. Remember, a string is just a collection of Unicode characters, so it's like an array of characters. The system itself has defined an alias of string, so if we use the uppercase word string and the lowercase word string, in C# they mean the same thing, and they're a string object, which is an array of char data types. The equality operators are equal, equal, and not equal are used to compare an object's reference location. With a string, however, the equality operators compare the string object's value We'd like to compare things lexicographically, and sometimes we can run into some problems with our comparison. So the string class makes many methods available, like I said, some of which allow us to do string-like comparisons and control things a little bit more. String objects are immutable. What does that mean? Well, that means that if I create a string named myString and give it a value of initial string, then in the code somewhere myString is updated to the value, another value. Both of those values remain in memory as long as that string exists. The object's reference points to the second value, the current value. So that's the reference location that would be referred to. This old string, the initial string, is just hanging out there in memory, just kind of taking up some space, but not really something that we can do anything with until the string is disposed of. A mutable string can be created using the string builder class. We have a lot of the same methods available to the string builder as there are available to the string class. So this string builder can be more efficient, definitely something that you want to take a look at, even though we won't get too in-depth in it in our class. New with Visual Studio 2015 and C# 6.0 was string interpolation. So you may not see this implemented a lot in code because it has been around for a very short amount of time. It's great stuff. We should update all of our code to do this. What we can do with string interpolation is instead of using those parameter replacement numbers like 0 and 1 within curly braces in our output statements, in our string formatting statements, we can actually use the variable name. So this variable should be named last, obviously, otherwise we'd have a problem here. But this would output the first name in this position, the last name in this position. So we can get rid of those numbers and get rid of the replacement parameters in our string format. So this string interpolation is a great thing. Definitely try it and try to get yourself used to using it. The BitArray class is another collection class that can be super handy. A BitArray is an array, so just like any other array, it's zero-based and it's fixed size like a standard array, but it just contains a bunch of Boolean values. So a bit array is something that we could use as an indicator as to whether a condition is true or false for each of several circumstances. So here's an example of declaring a bit array. Again, we have the class name BitArray, the identifier myArray, the new keyword telling Visual Studio or the system to instantiate this instance, and then our BitArray data type with an occurrence of 18. Now we're going to end up with this array that's going to be all true, all false, whatever, depending on how we initialize things. And one example of a way that we could use a bit array would be in a parking garage application. So here we have several parking spaces. We can have a bit array that keeps track of whether a specific parking space, parking number, is used or not. So if this spot in our bit array is false, the spot's open. If it's true, the spot is taken. So that's one way we could use a bit array. We could just indicate a lot of different situational informational pieces. Now another data type that can be important to us is called a hash table. And a hash table is an creation of a unique key based on string data or some other data. So for example, I have these keys here, people's names, and then I have this hash function that is going to take each of these names and hash through them using its own algorithm, come out with a unique key or a unique number to be identified with this name. Now in this example, Sandra D and John Smith here hashed out to the same value. So if that was a possibility within our hash table function, we would have to make sure to accommodate for that in our code. But basically I can use this to generate some sort of unique key for information. A queue data type is basically a line. We stand in line, and we know that in Europe they call that a queue. That's where we got the term. A queue is FIFO, first in, first out. If you get in line first, you hope to get out of line first, right? When we get in line, we call that enqueuing. We've gotten into the queue. When we get out of line, we've dequeued. Now, in our code, if we want to look ahead a little bit and see how many people are in line or what the name of the next person is, we could peek at that queue entry without dequeuing it. Otherwise, when we process it, we would dequeue it. So we can think of a queue, again, as just a line. When we enqueue, we get at the back of the line. When we finally work our way to the front, we dequeue. So again, if we were the first one in, we should be the first one out. A stack, on the other hand, is more kind of like some pancakes, right? So with a stack, it's the last one in that's the first out. So the top of our pancake stack is going to be the first one that gets eaten, right? So we have some terminology here for working with a stack type data structure. We push an item onto the stack, and then we pop it off the stack. Again, we can peek ahead at the stack to see what's coming. We actually use this stack implementation in a lot of different ways when we're programming. The operating system itself uses this stack implementation. Even when you're running a Visual Basic program, if you think about a Visual Basic program, the first method that gets pushed onto the stack is our main. When our main calls another method, that method gets pushed onto the stack. When that method calls another, it gets pushed onto the stack. When that method gets done executing, it gets popped off the stack, leaving us back to the earlier method. Finish it, pop it off the stack, and that drops us back to our main to continue executing. So we use the stack type data structure to keep track of operating system components also. Now, a good place that I've heard of somebody using a stack was just not even in code. It was in an interview, and they were asked in the interview how they would sort a list of names without doing something. Now I can't even remember. Bad story, huh? But anyways, they said, well, I would use the stack, and they got the job. So remember this stack data structure, that it is last in, first out. So I know what it was, reversing a name without using any of the string functions. So they were able to do a loop based on the length of the name and push each of the letters into a stack and then pop them off the stack, resulting in the name backwards. So good thinking and problem solving. All of the different C# collection classes offer you advanced capabilities and a huge amount of resources. MSDN contains definitions and lots of examples, so always be researching, trying to expand your skills. Have fun in your REPL course as you work through these examples, because it gives you a lot of power. You will be an excellent C# programmer. Thank you.